It's a good energy day here at KHW, where we highlight people, businesses, and communities doing good things for the environment. And this morning, we're talking about a new 3D printable clay-based concrete researchers at OSU say could help build infrastructure while slashing carbon emissions. Chris McGinnis shows us how.
Concrete is everywhere, from sidewalks to skyscrapers, but it comes with a massive climate cost. Traditional cement-based concrete accounts for roughly 8 to 10% of global carbon dioxide emissions. Now, researchers at Oregon State University say they've developed a faster, cleaner alternative designed specifically for 3D printing.
In my lab in the past year, we've developed a 3D printable clay-based concrete, which can be immediately cured right after it's 3D printed, and it can be used for building of housing, infrastructure, and things like that. And the amazing thing about our material is that it's using clay and soil, which can be sourced locally at the construction site.
Instead of relying on cement, the new material uses local clay and soil mixed with a small amount of special polymer binder that hardens almost instantly.
Traditional cement-based concrete accounts for about 8 to 10% of global CO2 emissions, and so it's very carbon intensive, but our material can essentially cut that down to zero or a very small fraction.
Speed is another major advantage. Current 3D printed concrete homes often require days of waiting between layers while the concrete cures.
For every layer that gets printed, they have to wait a few days for those layers to cure before they can come back and begin to print more layers. With our material, essentially it cures immediately, so we can print the entire house that same day.
The material also gains strength quickly, reaching structural requirements in a fraction of the time.
We found that these materials can achieve about 3 megapascals of strength immediately after 3D printing, which means you can print many layers one on top of the other. But then after only 3 days, we can get structural strength of concrete required for buildings and infrastructure, around 17 to 20 megapascals. Typically with cement-based concrete, this takes up to a month.
That speed could be critical after disasters, when roads, bridges, or buildings need to be rebuilt quickly.
If something breaks, like a bridge falls, a piece of infrastructure breaks, we can come in and we can immediately 3D print a new bridge, and it can be ready for use in the next few days.
There are still challenges. The specialized binder is expensive, and the material hasn't yet been tested for decades-long durability. But Roach says the urgency is clear.
In just the US alone, there's about 4.7 million houses that are needed to meet the demand. And so we need these rapid, on-demand construction materials and approaches that can sort of address this housing crisis and build houses quickly.
OSU Assistant Professor Devin Roach, who we heard from there, hopes to turn this laboratory-proven system into a business. He's now focused on lowering the costs and scaling up the materials so that hopefully one day he can build faster, cleaner, more affordable housing. And that's good energy.